Good evening. Last time we were looking at error recovery, and we added a few sort of bug fixes in. Tonight we're going to look at adding conditional execution so that we can finally define our Fibonacci function and see it operate. To do that, we're going to extend our token parser a little bit. We're going to add some more symbols into the operators, such as bar and ampersand, because we want those for and or, and we're going to want equality, we're going to want inequality, we're going to want less than, and we're going to want greater than. So we put all of those into our operators. We're also going to take advantage of putting in some reserved names, and the reason that we want to do that is that at the moment def and print and let could end up being used as function identifiers and so on, and that's not going to be helpful for us later. So let's add those reserved words in now. So we want let, def, and print to is it let, def, and print? One moment. Print, let, def. Yep. So we want those words to be now reserved. So that's a simple bug fix, and I will commit that and push it up as a separate commit. So we want to add conditionals to our calculator. I want conditionals to be first class in the sense that I don't want them to be ordinary expressions. So I'm going to define a conditional data type, or condition data type, which first of all could be the AND combination of two conditions, or the OR combination of two conditions, or the inverse of one condition, or it could be an equality test between two expressions, or it could be a less than between two expressions, or it could be a less than equal between two expressions. Now that's enough to define all of the different conditions that we might need. Not equal can be defined as a not of an equal of two expressions. Greater than is a not less than or equal, and greater than or equal is a not less than or. So we have all of our types of comparison in there, and our three Boolean operations. We also want to add a conditional expression type, which can be fairly easily decided on as condition like that. And we're going to add some reserved words to let us do this, and the reserved words that we're going to use are if, then, and else, because what else would we use? So one of the first little bits that we're going to do is we're going to add a term to our parse term, which will be a conditional term. So let's say try parse conditional, and parse conditional will be a parser for expression. And in order to parse a conditional, we're going to have a reserved if, then we're going to have a parse condition, which we're going to write later, then we're going to have a reserved then we're going to have our first expression, a reserved else, and our second expression. Finally, we're going to return conditional C E1 E2. So what this is going to do is it'll pass something like if x is equal to y, then 12, else 14, that kind of thing. And this will allow us to terminate our Fibonacci recursion. We now want to write our expression parser for conditional expressions. So let's try parse condition is a parser which is going to return a condition, and it's going to be flip build expression parser of parse conditional term and some list, and our list is going to have an infix of reserved op. I'll tell you what, let's actually use the not symbol for negation, for unary negation. That seems like a fun symbol to use. So I've added it to our reserved operator symbols, and that's just going to return not. And that's all we need for our infix ones. And then we're going to have our sorry, not infix, that should be prefix. I can spell, can't I? Infix, a reserved op of and is going to return and that's going to assoc left, and an infix of reserved op or is going to return or and assoc left. And now we need just a little bit of tweaking in order to get our yep, no parts conditional term, excellent. So in order to get our expressions to turn into conditionals, we're going to need to write out a little parser of our own. It's going to be a bit icky, but you know, it's the way it goes. Fortunately, it only needs to support the concept of an expression, a binary operator, and another expression. And then we need a function which, when called, will do the right thing. So let's do that. Parse conditional term of is going to be a parser that produces a condition again. And a conditional term will be parens of parse condition, or it will be parse fundamental condition. Right, let's say parse comparison, since effectively we're just after comparisons at this point, and the comparison will be a condition and it's going to get an expression. That's our first step. Our second step is going to be to get some function. Now we might be dealing with an equals, in which case we can return equal, or we might be dealing with a less than, in which case we can return less than, or we might be dealing with a less than or equals, in which case we can return less than equal. Now come the clever ones. Reserved of greater than is going to be return, and then we're simply going to dot not with less than equal, or the greater than or equal to will be not dotted with less than, and obviously the final one, the not equal, will be not equal. So f is now a function that, when given two expressions, is going to give us back a condition. So let's get our second expression. And finally, let's return f of e1 and e2. Now, what have we messed up here? Could not match type expression to condition. So less than equal takes two expressions and gives back a condition. Not will then take that condition and return it. What have I messed up here? Ooh, a stone with a smiley face on it. Hi. While I was waiting for the previous section to encode, I finished off our parse comparison function. What I had to do was switch things around so that we returned a function that only took one expression when we parsed our operator, and that's so that the dot operator will work, because we can't dot together two functions if the second function takes more than one argument. Is not allowed. So now we have a comparison function. We have our conditional term, which will either parse a parenthesized condition or one comparison. We have our condition parser that will either parse not a condition, or it will parse a condition and a condition, or a condition or a condition, or just one conditional term on its own, just like our expression parser will parse expressions. We have a conditional expression parser, the if then else. So what's left to do is basically add that to our interpreter. So the first thing that we notice is interpret expression is underlined in yellow, and the reason for that is that we need to add an interpret expression for the conditional. So let's do that. And that should do the trick. Interpret condition. Right, so what we need to do now is write an interpret condition function. Let's get that up here. Interpret condition, which will be a condition and produces a boolean. So different types of conditions. Well, let's do the easy one first. A not condition is going to be interpret condition C, bind to, return dotted with an ordinary not. Interpret condition of that will be that should do for and. Let's do the same thing, but obviously with the or operator for or, and approximately the same thing for equal, except obviously we're going to have to interpret expressions rather than conditionals, and we're getting values back, and we want value 1 equals value 2, and we can then do less than and we can do less than equal, and so our interpret condition is finished, our interpret expression is finished. We've got nothing to add to interpret statement, so let's go ahead and have a go with our calculator. Step 1, let's just try a simple conditional expression. So if 1 equals 2, then 1 else 2 should print as 2. That looks pretty good. So let's jump in at the deep end. Let's write our Fibonacci function. So def fib of n. If n is less than, now most people say fib of 1 is 1, fib of 2 is 1, fib of 3 is 2, and so on. I tend to prefer to start at 0. So I'm going to say if n is less than 2, then 1. Else fib of n minus 1 plus fib of n minus 2. What have I messed up? Oh, I needed to have an equal sign in there because I can remember the syntax from day to day. Oh yes. So we've now defined a Fibonacci function, and print a fib of 0 is 1, print a fib of 1 is 1, a fib of 2 should be 2, a fib of 3 should be 3, a fib of 4 should be 5, and a fib of 5 should be 8. So we've got recursion working with multiple calls, with conditionals, and that's all happening for us automatically. We could write mutually recursive functions if we wanted. It will now all operate as we want. Again, I will commit and push this to the Git server. Please feel free to clone it. check out the code, have a play with it, see what else you might be able to do, and try all the different kinds of conditions out. Don't forget to subscribe, follow me on Twitter, leave comments below if you have any ideas, and otherwise I will see you next time. Bye bye.